Wonderful people, let's continue in our work, and we will be looking at the hyperbola. And one of the most important things we will look at is the definition. Of course, there is only one difference in the hyperbola compared to that studied last year. They refer to grade 10, and that is the horizontal translation is now included. So meaning last year the vertical translation was talked about, and this year the horizontal translation is now included. So having studied transformation geometry last year, this should be an easy addition to the graph. Most of this is just refreshing the knowledge that you have already learned. Now the equation in the standard form of a hyperbola would be that y equals k x plus p plus q. So this is exactly what we will be looking at. And what are we saying here? We are saying this is the vertical translation and the horizontal translation. The most important feature of the hyperbola is the quadrants in which the graph occurs relative to its asymptotes, which gives the shape of the function. So one thing that we should know is that the value of k determines the quadrant relative to the asymptotes where the hyperbola will lie. So the value of k tells you the quadrants where the hyperbola will lie relative to your asymptotes. Okay, so we are therefore saying the following. Let me just draw up a line. If k is positive, what is it that we should know? X and y. It will be on the first and on the third quadrant. If we look in terms of the mother graph, y equals k over x plus 0 plus 0. So when the horizontal and the vertical asymptotes are 0, that means the y-axis and the x-axis becomes your asymptote. This is very, very important that we understand this. Asymptote being a line that the graph will approach but will never reach. This line will approach the x-axis but will never and ever get exactly at that line. So this becomes the horizontal asymptote, and this becomes your vertical asymptote if you have the mother graph y equals k over x, where the vertical asymptote is 0 and the horizontal asymptote is 0. This is very, very important. And I know that x is 0 along this line and y is 0 along this line. Okay, so that is when the value of k is positive, and when the value of k is negative, it would lie on the second quadrant and the fourth quadrant. And this is y equals negative k over x. If x is 0 and y is 0, you have the y axis as your asymptote and your x-axis as also the asymptote. All right, so that is fine, that is very much fine. So your horizontal asymptote, if you have y equals k x plus p plus q, your horizontal asymptote would be x plus p equals to 0, this, therefore x equals minus p, and your vertical asymptote and your vertical asymptote would be q. So your y is equals to q. So this is your horizontal asymptote and this is your vertical asymptote. So this is your horizontal and this is your vertical. Okay, that is fine. Therefore, the equation of the asymptote is x equals minus p. You will notice that if p is positive, the asymptote would be negative. Yes, if p is positive, the asymptote would be negative. And when p is negative, the asymptote would be positive. That is to say, if you have y equals k x minus p plus q, if p is negative, the asymptote would be positive. And if p is equals to 0, the asymptote will coincide with the y-axis, because on the y-axis x is equals to 0. But I think this will be thoroughly explained when we deal with the examples. So in order to find our asymptotes in y equals k, x plus p plus q, the coordinates of the asymptote would be minus p and q. So the value here, you will say x plus p equals to 0, p equals x equals minus p, and then the value of q, you will take it as it is. This is very, very important that we understand that. And then we also have the equation of the axis of symmetry. Symmetry is a very important feature of the hyperbola. To determine the equation of the axis of symmetry that intersects the graph, we use the equation of a straight line. This is very, very important. Y equals mx plus c, with m equals 1 for k that is positive, and m equals minus 1 for k that is negative. So meaning the equation of the axis of symmetry, the gradient is equals to 1 if k is a positive number, and the gradient equals minus 1 if k is a number that is negative. This is very, very important that we understand this. The point that is used to substitute for x1 and for y1, or for y equals mx plus c, the point that is used to substitute for y and for x is what? Is the origin of your asymptote. So you take in the value of p and the value of q to substitute in order to find the equation of the axis of symmetry, okay, which is a straight line. So if the value of k is positive, the gradient is equals to 1. You are using this equation, substituting the coordinates of the asymptotes in order to find the equation. If k is negative, the gradient is equals to minus 1, and you are substituting the values of x and y for the asymptote. Okay, if that is fine, then let's go and try to look at the table of coordinates. So meaning applying the translation of points from transformation geometry done last year, a table of easy values can be determined using the value of k. X1 times y1 equals k. Then each point translated in essence x minus p and y plus q. Let us just try to look at an example of this. Suppose we have the following. Suppose we have that y equals 8 divided by x plus 2 plus 3. Right. And what is it that we want to do here? Let me just bring the camera a little bit closer. Very good. Suppose this is what we have. And we want to we want to have an ordered pair of points. So first of all, we would see that the value of k is positive. Okay, therefore I have my asymptotes minus 2 and 3. So how am I going to find the points that accompanies this function in order to draw the function? So using the value 8, can we be able to find the values, a set of coordinates that might help us to have some points? Right. We have 8 divided by x plus 3 plus 2. So what we're going to do for vertical translation, which one is responsible for vertical translation going up or down? That's y. So suppose that we have the points that are given 2, 4, 4, 2, 8, 1, 1, 8. Suppose these are the points that we have. And for every translation, we will try to add 3 to the y coordinates, and for the horizontal translation we will subtract 2 because this is x plus 2, therefore x equals minus 2 from the x coordinate. So what are we going to have here? We will say, okay, I have a 2, so I'm going to subtract 2 in here, so I'm going to have minus 2, and then for y I'm going to add 3. This is very important. And then I'm going to say 8 minus 2. For 1 I'll say 1 plus 3. And then here I would say 1 minus 2, and I would say 8 plus 3. And what values do I get? 0, 7, 6, 4, minus 1, and 11. What is this? Applying the translation of points from the transformation geometry done last year, a table of easy values can be determined using the value of k. So what are we doing here? What have we done? We are taking the value of x and the value of y, and whatever that we get here, this is equals to k. So we are taking x1 and y1, multiplying together, and this is equals to k. And then each point is translated x minus p plus or minus the square root of k plus q. Yo. So what we are saying here, if we have the x values that are provided to us like this, and we want to translate each point 2 units to the left or right and 3 units up or down. So what do we do? Based on transformation geometry, we come here, we solve for x plus 2 equals to 0, therefore x equals minus 2. From every x value that we are provided, we will subtract that 2, and from every y value that is provided, we will add 3. This is how transformation works, and these will be the translated points that we will get simply by just using that. That's exactly what I have been trying to do here, translating the points 2 units to the left and 3 units upwards. That's exactly what I have done here. Okay, that is fine. What is it that we want to do once again? Now, let's try to sketch the function f maps x onto minus 6 divided by x plus 3 minus 4. We should show the intersections with the x and y and the symmetry axis. This is what they want. Okay, I know that if the value of k is negative, the graph has to be on the second and on the fourth quadrant. Okay, and the translation or the asymptotes, my asymptotes would be that would be x plus 3 equals to 0, x equals minus 3, and y equals minus 4. Okay, those are my asymptotes. The coordinates would be minus 3 and minus 4. Okay, and then I can find the equation of the axis of symmetry. I know that if the value of k is negative, the gradient is equals to minus 1, and I'm substituting this. So meaning y equals mx plus c. My y is minus 4. The gradient is minus 1. X is minus 3 plus c. And minus 4 equals 3 plus c. And my c is minus 7. So this is y equals minus x minus 7 as the equation of the axis of symmetry. Okay. Now, how will I find the point of intersection between the straight line and the function that I have, which is this. Now I want the point of intersection, and I know at intersection the graphs are equal. So I would say minus 6 x plus 3 minus 4 equals minus x minus 7. Okay, so here minus 6 x plus 3 minus x minus 7 plus 4 minus 6 x plus 3 minus x minus 3. This is what I would have. And from here, let me just turn the pages. So I have minus 6 x plus 3 minus x minus 3. This is what I have. Okay. So what are we going to do here? What we can do from here, I can take out a negative as a common factor here. Okay, and I can multiply both sides by x plus 3. And this into this goes once, and I have minus 6 equals minus into x plus 3, that is squared, because remember this is what I have. And then remember what transpires here. I can divide by negative, and I can have x plus 3 squared. I can square both sides, and I can have x plus 3 equals plus or minus the square root of 6. Okay, so that is fine. I can take this to the other side, so meaning I can have plus or minus root 6 minus 3 is equals to x. Okay, so what I can do from here, this is an x value that I have found. I can find the corresponding y value by substituting this either in this equation, this one, or in that one. So let's substitute in this one, minus x minus 7. So y equals minus x minus 7. So my x is this, so I can say minus into plus or minus root 6 minus 3 minus 7. And what is it that I can do from here? What is it that I can do from here? I think what I can do, I can have plus or minus root 6 for this, and negative multiplies here becomes positive 3 minus the 7, plus or minus root 6 minus 4 as the corresponding y value. So the point of intersection is plus or minus root 6 minus 3 and plus or minus root 6 minus 4 as the point of intersection. Okay, so I can translate the point. Suppose that I have the point minus 1 6 minus 6 and 1 minus 2 and 3 minus 3 and 2 1 and 6 6 and minus 1. Suppose these are the points that I have. Okay, so if we are to translate these points according to x, remember what we have is this. Remember we have this x plus 3 and y minus 4. So I can translate on x minus 3 and y minus 4. So if I translate that, what is it that I can do from here? Let me just write this down for you. Minus 6 divided by x plus 3 minus 4 and y equals minus x minus 7. So I'm subtracting 3 from x and I'm subtracting 4 from y. So in this first one, I'm going to have minus 1 minus 3, which will give me minus 4. And in this one, I'm going to take the value of 6 and I'm going to say 6 minus 4, which is 2. And I'm going to repeatedly do that to every point until I have these values. And we can have those points being translated. Okay, that is fine. And then what else is needed? It's the intercept with the axis. And I know for y, intercept x is equals to 0. So y would be minus 6 into 0 plus 3 minus 4. And I would find a value of minus 6 over 3 minus 4 minus 2 minus 4, that would be minus 6. And then for x-intercept, y would be 0. So 0 will be minus 6. X plus 3 minus 4. Take this to the other side. 4 equals. And then I would just cross multiply. Okay. And then I can divide by 4. X plus 3 equals minus 3 over 2. Take to the other side. And you will find your x is minus 3.5 minus 3, which will give you a value of negative 4.5. Okay. That is fine. So I have the x-intercept, y-intercept, the equation of the axis of symmetry, the intersection point, the translation from one to another. And now I can be ready to draw up the graph. So I have my asymptotes. Remember, x equals minus 3. This is very, very important. So let's say we have minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Right. And from here I have my asymptote minus 3. So this is what I will have. Okay. And then we have y of minus 4. So this would be my minus 4. Okay. Okay. And then from there, what else do we have? We have a point of intersection. If you remember, there it is. So let me start first with my x and y intercepts. So y-intercept is minus 6. There it is. And I have my x-intercept of minus 4.5. And this is the same as negative. Remember this. Let me just simplify this for you. And this you would get minus 9 over 2, which is negative 4.5. Okay, so that would be a value. This is my x-intercept. So let's say maybe this value is negative 4.5. And where is negative 4.5? Negative 4.5, it's somewhere here. Okay, this is fine. And I can now draw the function. I can draw up the function. I can draw up the function, and the function would look something similar like this on the second quadrant and on the third quadrant. And you will just have to place your coordinates there. For example, let's try to check something. We would see that when x is minus 4, y is 2. So when x is minus 4, y is 2. For x is minus 4. So that's a point somewhere there. And when x is minus 9, y is minus 3. So minus 9 might be a value somewhere here, and minus 3 may be a value somewhere there. So if we continue in this line, you might find out that the value there has to be a value somewhere around. They have to lie around your straight line. Those might be some of the points that you can have, but don't do it the way I'm doing this. You just have to plot these points exactly as they appear from there, and you will have these points. And then remember, we have the equation of the axis of symmetry, and we have the point of intersection of this. Okay, so this is a line that cuts the it goes through the asymptotes. So you might have something like this. Very, very important. So what is this? This is the line of symmetry. It goes through this, and then this is exactly what you will have, because the gradient is negative. Remember, it will face like this. If the gradient is positive, it would have faced in that direction. I don't know if this is making sense. Right, I'm going to break it here, wonderful people, and we will continue in the next tutorial.